It's a land piled high with ice, whipped by fierce winds and powerful ocean currents. In a world buffeted by rising temperatures, rising sea levels, and changing climate patterns, what is the fate of Antarctica? If you could go back to a time 250 million years ago, what's now the frozen continent of Antarctica was a land of forests and flowing water. In a warmer, wetter world, it harbored a wide diversity of plants and animals. In this period, known as the Permian, Antarctica was at the southern end of a vast single continent that spanned the globe, called Pangaea. Within the sweeping evolution of this grand continent, a single event would reverberate down through history. An asteroid headed toward the southern hemisphere. At up to 50 kilometers in diameter, it would have been 4 to 5 times larger than the one thought to have killed off the dinosaurs. It crashed into a region that's now part of East Antarctica. But its impact was global in scale. One theory is that it sent powerful seismic waves to the exact opposite or antipodal side of the Earth. On what's now Siberian Russia, a plume of magma pushed up through Earth's crust. For tens of thousands of years, lava flooded the landscape. A release of toxic elements, a rush of carbon dioxide into the atmosphere, acid rain, all led to one of the worst mass extinctions in history. 70% of all species on the planet vanished. On Earth, traces of most major impacts are obscured by erosion or geological activity. A new type of observational tool is now allowing scientists to see them. In 2002, they launched the twin spacecraft of the GRACE mission, short for Gravity Recovery and Interior Laboratory. Its goal was to map subsurface features by measuring variations in Earth's gravity. A gravitational surge, or a dip, causes the distance between the two craft to change, which GRACE measures down to the width of a human hair. Down along the eastern part of Antarctica, GRACE detected an immense subsurface presence. Scientists matched it up with subtle rings etched on the wider landscape and with chemical traces found in nearby mountains. They concluded that a large meteor had struck at the end of the Permian. It would have a lasting impact on Antarctica's long and tumultuous journey. That journey began in the breakup of an immense continent known as Rodinia, beginning around 750 million years ago. In those days, Antarctica basked in the tropical sun. Some 300 million years later, Earth's land masses reshuffled into the supercontinent Pangaea. When Pangaea finally fragmented, Antarctica began a steady drive toward the southern pole as part of the great southern continent of Gondwana. At around 130 million years ago, a series of rifts developed in Earth's crust, tearing South America and Africa away from Gondwana. Australia finally split off at about 85 million years ago, leaving Antarctica on its own. Because the rift between the two cuts through the Permian crater, one theory holds that the force of the impact may have actually initiated it. Now separated from its sister landmasses, Antarctica carried a rich biological legacy, evident in fossils recently pulled from the frozen ground. The Cryolophosaurus, from 190 million years ago, was in a class of meat-eaters called theropods. These bipedal creatures gave rise to some of the fiercest predators ever, including T-Rex, as well as modern-day birds. Out on the West Antarctic Peninsula, scientists turned up a smaller theropod from 70 million years ago. This swift predator would have grown to about 2 meters in length. From the same period, another group found a young plesiosaur, a marine reptile that plied warm southern oceans. If it had reached adulthood, it would have grown to around 10 meters in length. From a continent that once hosted dinosaurs, Antarctica grew steadily more hostile to life. Wind the clock forward 50 million years ago. All around the world, warm conditions were giving way to cooler, drier times. The new era saw a decline in the heat-trapping atmospheric gas, carbon dioxide. Around Antarctica, conifers and other cold-tolerant plants took hold. In some areas, they gradually turned to tundra. Ice remained year-round, gradually forming a thick sheet. At the same time, powerful wind currents circling the pole from west to east drove the circumpolar ocean current. Known as the mightiest current in the world, it helped shield the continent from tropical waters to the north. A combination of factors came together: declining CO2, the isolation of Antarctica, and the tendency of permanent ice stores to reflect more solar energy back to space. At around 2.5 million years ago, Earth entered the last great ice age, the one we live in, called the Quaternary. Year after year, as storms rolled off the oceans, they deposited layer upon layer of snow and ice across Antarctica. Today, fully 70% of all the fresh water on the planet is here, in ice that averages nearly 2 kilometers in thickness. Antarctica today is known as the windiest, driest, and coldest place on Earth. There are no permanent human populations, only a few thousand scientists and support workers living at scattered research stations. At the Russian Vostok station in July 1983, scientists documented the lowest natural temperature on record, minus 89.2 degrees Celsius. A recent calculation based on satellite data went even lower, to minus 93.2 degrees Celsius. But as cold and isolated as it is, Antarctica is not immune to changes in the larger environment. Take, for example, this reconstruction of the continent during the last glacial maximum 20,000 years ago. Compare it to this image of the current interglacial period. It shows how much ice the continent has shed. In recent years, the rate of ice loss has picked up speed. Scientists have turned to satellites to find out where and how quickly this trend is playing out. In these images from the GRACE mission, areas that lost ice are shown in blue, while orange and red gained ice. European scientists backed up this finding with radar data from the Cryosat-2 spacecraft. By tracking changes in the elevation of Antarctic ice, they found that the continent lost on average 159 billion tons of ice each year from 2010 to 2013. That's an increase of 31% per year over the previous 5 years. Like GRACE, Cryosat-2 found that the greatest losses have occurred in West Antarctica, especially where a series of fast-flowing glaciers empty into the Amundsen Sea. A small number of scientists were warning about this as far back as the 1960s. The reason, they pointed out, is the intensification of winds that encircle the continent. As the temperature difference with northern regions has increased, these winds have picked up speed. To sailors brave enough to venture into them, the Southern Ocean once offered the quickest route around the world. Nowadays, stronger winds have had the effect of drawing to the surface relatively warm water that occurs naturally in the depths of the ocean. These warmer waters have begun to undermine a series of vast floating ice shelves that extend out from inland glaciers. Scientists, using data from the IceSat spacecraft, documented this effect by correlating areas of greatest ice loss with the location of submarine troughs that can funnel the warm water up. These satellite images from over a decade ago show the effect this can have. Out on the West Antarctic Peninsula, the Larsen Ice Shelf extended out over the ocean. This image from early February of 2002 shows Larsen beginning to splinter. By March 7th of that year, this ice shelf, hundreds of meters thick, broke apart. Countless icebergs tumbled into the sea. Without the shelf's buttressing effect, the glaciers behind it picked up speed, dumping an additional 27 cubic kilometers of ice into the ocean each year. This has led scientists to monitor the other great ice shelves of West Antarctica. One team set up its base on the Pine Island Glacier, where it juts out into the Amundsen Sea. From the surface, they drilled down through 500 meters of ice. They found that warmer waters had been eroding the underside of the ice shelf, with melt rates of about 6 centimeters per day, or about 22 meters per year. Another group has been using satellite and airborne radar to track the changes on a regional scale. Red shows where the glaciers are traveling at their highest speeds, at the intersection of ice and ocean. The flow speed is steadily increasing. The darker the red, the faster the ice is moving. Some of the most dramatic changes have been observed on the Smith Glacier, one of the smallest in this group. Back in 1996, it can creep into the subglacial basins. For most of the glaciers, there are no major barriers, such as hills or mountains, that would slow them down once they get going. The danger is, the more the glaciers speed up, the more likely the ice sheets behind them will collapse. If that happens, it may not be completely due to climate change. Scientists have found that the flow of water beneath some glaciers is too high to come just from seawater. The Transantarctic Mountains, dividing East and West Antarctica, are the product of a rift that is occurring in the underlying crustal plate. Scientists have detected seismic activity they say is consistent with magma moving within the crust over 25 kilometers down. They have now found there is a significant amount of geothermal activity beneath one of the largest glaciers, the Thwaites, to account for the extra melting. To date, most studies of future sea level rise have focused on the ice sheets of Greenland and Western Antarctica. Together, they would account for up to 12 meters of sea level rise. The massive East Antarctic ice sheet has been largely ignored. Because of its sheer size and unwavering cold, it has seemed impervious to warming trends in the north. New research has given scientists reason to wonder how stable it really is. One new study takes us back to a period called the Pliocene, from about 5 to 2.5 million years ago. Back then, global temperatures and atmospheric CO2 concentrations were about where they are projected to be at the end of this century. Sea levels are thought to have been at least 20 meters higher than today. If any part of East Antarctica had melted, it would have been here, in a region called Wilkes Land. This is where the GRACE satellites detected signs of the massive Permian impact. There is enough ice here to add another 3 to 4 meters of sea level rise. If the glaciers of Wilkes Land are prone to melting in warmer times, then erosion would have washed its distinctive volcanic soils into the sea. By drilling down into ocean sediments, scientists were able to find them just offshore. They concluded that in the Pliocene, seawater was able to erode rocks about 160 kilometers inland. How stable is the Wilkes ice sheet today? Currently, it is said to be in balance. This means the amount of ice that melts or falls into the sea is replaced by new ice that forms inland. Scientists used a computer simulation to find out what it would take to throw Wilkes out of balance. A crucial factor of their calculation is a zone in which the ice shelf is wedged against a series of ridges on the sea bottom. These ridges act as a stopper, preventing the glacier and the ice sheet behind it from moving forward. If warmer waters were to undermine the ice that rests on these ridges, then the ice sheet could begin to move out to sea. The effect has been described as that of a bottle of water tilted downward. Remove the stopper, and gravity empties it out. For a glacier, once the ice starts flowing, there would be no stopping it. How plausible is this scenario? On the much smaller Pine Island Glacier, scientists have shown that the ice shelf has already broken free of an undersea ridge. The disintegration of coastal Antarctic glaciers is a process that would take centuries to run its course. But once it gets going, it would mean a steady rise of sea levels for the foreseeable future. The changes we experience in our everyday lives are shaped mostly by near-term developments in technology, politics, and culture. Some of the bedrocks of modern life, cities like New York, London, Hong Kong, and seaports around the world have grown and evolved on the scale of centuries. Within the long arc of their histories, rising seas could threaten their existence in a relatively short time frame. The emerging story of ice sheet melting and sea level rise is often couched in uncertainties, with the drama of what's happening damped by the rational language of science. Critics focus on the margins of error inherent in the scientific process, or downplay the predictive power of computer simulations. Politicians debate, while conspiracy theories abound. One of the lessons of Antarctica is that our choices are beginning to narrow. The trends we see now will increasingly shape the fate of Antarctica and that of the world we know. Or antipodal side of the Earth. On what's now Siberian Russia, a plume of magma pushed up through Earth's crust. For tens of thousands of years, lava flooded the landscape, a release of toxic elements, a rush of carbon dioxide into the atmosphere, acid rain, all led to one of the worst mass extinctions in history. 70% of all species on the planet vanished. Parade down through history. An asteroid headed toward the southern hemisphere. At up to 50 kilometers in diameter, it would have been 4 to 5 times larger than the one thought to have killed off the dinosaurs. It crashed into a region that's now part of East Antarctica. But its impact was global in scale. One theory is that it sent powerful seismic waves to the exact opposite. On Earth, traces of most major impacts are obscured by erosion or geological activity. A new type of observational tool is now allowing scientists to see them. In 2002, they launched the twin spacecraft of the GRACE mission, short for Gravity Recovery and Interior Laboratory. Its goal was to map subsurface features by measuring variations in Earth's gravity. A gravitational surge or a dip causes the distance between the two craft to change, which GRACE measures down to the width of a human hair. It's a land piled high with ice, whipped by fierce winds and powerful ocean currents. In a world buffeted by rising temperatures, rising sea levels, and changing climate patterns, what is the fate of Antarctica? If you could go back to a time 250 million years ago, what's now the frozen continent of Antarctica was a land of forests and flowing water. In a warmer, wetter world, it harbored a wide diversity of plants and animals. In this period, known as the Permian, Antarctica was at the southern end of a vast single continent that spanned the globe, called Pangaea. Within the sweeping evolution of this grand continent, a single event would reverberate.